Right, welcome to the final review. So for this, I know I sound probably a little bit different. I am using my desktop because for some reason the file want to go from my desktop to the my tablet. So the final is going to be next week, Tuesday, so 12/7. It's going to start at 11:30 a.m. So for the general stuff, again, calculators are used. The equation sheet that is currently I'm thinking you'll need is currently up now. There's a small chance it gets modified. I will update it if it does. Have whatever you need for writing and erasing purposes nearby. The exam this time will be 2 hours instead of the hour and a half. This is a longer exam, and as such, you need some additional time. Again, for the exam, this part's the same. It's individual, closed notes. Can't work together, can't use your notes. General, you got to show work. Each problem solving question has to be on its own page. You don't have to print it out. Make sure everything is legible. Again, you guys did pretty good on this and have continued to do pretty good on it, so just keep doing that. The exam this time, it is a little bit longer. Now you have 10 true false and 10 multiple choice questions. Again, this is the conceptual portion of the exam, quick math type things. And then you will have 4 problem solving questions. Each is worth 20 points. So this means that they will probably be less lengthy questions, kind of more comparable to the 20-point questions, less really long no really long questions. So at most 3 parts, or maybe the third part is a yes or no, or just combining, a vector's components into a single value. Partial credit, again, you guys are doing really good on this. So writing out your knowns, unknowns, starting equation, pictures. Couple of you probably could do better on showing some work. But in general, pretty good job. If you end up needing a second page, use the second page. Even if you don't feel like you get anywhere on the question, throw that work together, connect it with some arrows, at least try to get some credit for that. So I want to talk about the learning objectives. So these were on the syllabus. We've talked about them for every exam. These are what you are supposed to learn at the end of the class, and this is what I'm going to be focusing on for the exam. So explain the core concepts in mechanics for forces, motion, momentum, and energy. You'll notice if we skip down to the third bullet point, the appropriate skill sets at the pre-calculus level to problems involving forces, motion, momentum, and energy. There are 4 topics here. There are 4 problem-solving questions in this exam. You'll probably have a question on forces. You'll probably have a question on motion. You'll probably have a question on momentum. You'll probably have a question on energy. So those are the 4 topics you are 99.9% likely to see for problem solving in the exam. You're going to have to deal with vectors, forces, certain types of motion, and momentum are all vector-based. You will probably have something in 2 dimensions for 1, 2, or all 3 of these. Energy is not a vector, so don't worry about vectors for energy. You will need to analyze the connection between calculus and physics. That is the derivative and the integral. I wouldn't expect that to be terribly terrible. Just, go through and can you do or relate this function to the correct derivative? Something along those lines. But it very clearly states in the learning objectives that you need to apply the appropriate skill sets for solving at the pre-calculus level. So that means if there is calculus, it will be in the conceptual portion of the exam. So if we look at forces, motion, momentum, and energy, you may notice that that does not really cover what we've been talking about really since, I don't know, we finished simple harmonic motion. it's going to tell you an indicator. Don't spend a lot of time on that part because it's not really, or no, I guess we did forces with Coulomb's law. But that's really it, right? We haven't looked at motion very seriously when it comes to, when we're looking at circuits, that's not mechanics, that's electrodynamics. So probably not something you want to spend a lot of time on. All right, so let's go ahead and the chapters on what to study and ignore. In reality, from chapter 1, all you need out of it is SI units and conversions. The conversions being like centimeters to meters, that type of thing. Making sure you know the SI units, so knowing do you go to meters, kilograms, that type of thing. In general, you guys have been doing a pretty solid job on that. Every once in a while, the conversions haven't turned out right, so just make sure you're comfortable with centi, milli, kilo, kilo. I think those are the big ones that you probably need to know. So make sure you know what those are. Chapter 2, we talked about 1D kinematics. So be able to do, probably not going to have a 1D kinematic question, but this is where we learn the relationship between position, velocity, displacement, velocity, acceleration. This is where we first saw the derivative. This is where we first saw the integral. So being able to do those and understanding how to, even though we're moving in 2 dimensions, typically, if we change our coordinate system on an incline, we can move in 1 dimension. So that is something that would probably be beneficial to look at. Chapter 3, look at how to combine and take apart vectors and vector notation. This is kind of scattered all throughout chapter 3. We're not going to be doing graphical representation, so yes, understand to draw a vector is to just draw an arrow, but don't worry about vector addition, vector subtraction, any of the graphical ways to add up vectors. Focus on the mathematical part, so, v is equal to vxi hat plus vyj hat plus vzk hat, that type of thing you should focus on. How do you take a vector with a magnitude and an angle, split that into x and y components? How do you take that x and y component, put it back together to a magnitude and an angle? That is what you need to focus on from chapter 3. Chapter 4, we ended up covering almost the entire chapter by the end of the class. So, projectile motion, it will not be combined with uniform circular motion, centripetal acceleration, or non-uniform circular motion. This would be separate category. But, projectile motion, we talked about 2D kinematics with some very specific rules to it. So acceleration in x is 0, acceleration in y being negative g. There will be a review video on kinematics that pops up. It's probably going to be the last video I end up doing for the review, so that might not show up until the weekend, but there will be a review video on projectile motion. The only thing we didn't cover in chapter 4 is relative motion. I don't think you really need it right now. You'll probably see it in your 130 class. For the circular motion stuff, from here, really what we learned are the rotational variables. So theta, omega, alpha, how to convert back and forth between them, and then how to use kinematics for rotational variables. So chapter 5 is where we start getting into forces and in particular Newton's laws. So this is chapters 5 through 7 where we talked about them. So these are probably all going to be combined into one type of question. So know how to do a free body diagram. Again, free body diagrams come with coordinate systems. So no coordinate system, no full credit. In chapter 5, you learn about Newton's first and second laws. You don't know how to use them till 6, but we have covered chapter 6, so that is fair game. You might want to check out sections 1 through 4. It talks about some of the forces in more detail. So for example, it'll talk about gravity. It talks about, I guess not really friction. It just doesn't talk about friction and tension in all their detail, but it talks about what they are, how they get used, the variable, and so forth. But again, remember in this class, you are an adult. You can choose the variable you want to use. Just make sure it's clear. Chapter 6 is where we learn how to use Newton's first and second laws of motion. Just know the difference of mass and weight. You're not going to need to calculate weight for something that's moving up and down. Know the difference between static and kinetic friction, when to use each, and how to calculate them. And you'll be able to just flat out ignore drag. I think we looked at the equation and said that's gross and moved on. Chapter 7 was the last one where we're introducing new information about Newton's laws of motion, where we learned about the third law. So in section 3, this is where it's introduced. Section 5 is a bunch of examples. If you haven't done them yet, I recommend checking them out because it's going to have ropes, pulleys, and I don't think they all have inclines, but there's a chance there's an incline or two in there. So this is all fair game. You can ignore some of the terminology and the interaction diagrams that are introduced in 7.1 and 2. So everything up until this point, so really chapters 2 through 7 have to deal with kinematics and forces, which we saw are heavily related to each other, right? We can use forces to calculate the acceleration of an object and how that acceleration of the object can then be used to calculate a velocity or a position, depending on exactly the information you have. Now, you are most likely not going to see a combined question in this class. However, for Physics 130, that is something that is much more likely. Here, we don't have any 25-point questions, so I'm probably not going to be doing that. We skipped all the way then to Chapter 9, where we started introducing energy. So again, energy being all scalar based, so we didn't need to worry about that. I would understand the work energy principle. So this is how forces and energy, in particular kinetic energy, are related to each other. Be able to calculate work in all of the different ways. So that is the dot product. That's the area under the curve. That is the equation. What is in this textbook? I don't remember if it's F S. I think it's S, whatever the variable is, and then the cosine of theta. So know how to use those different ways to calculate work. This is where thermal energy, so the energy due to friction, is introduced. So this is, if you want to kind of review that, it would be here. For the sections to ignore, we didn't talk about power. We didn't look at, I mean, we did do work on a spring, but eh. And then again, in this class, I'm not going to make you regurgitate a proof. I think that's absolutely silly. So here we introduced kinetic energy, 1/2 mv squared. So if you go back and you look at what you are supposed to learn in this class, it doesn't say anything explicitly about work. So if there is work, it's probably going to be in the conceptual portion of the exam. 10 is where we introduce the conservation of energy. First, we have our two types of potential energy, gravitational and elastic. Know when to use both of those. We had conservation of ideal energy and non-ideal energy. There will be a review video on the conservation of energy with both no and yes on friction. Conceptually, it's fair game to put energy diagrams and conservative and non-conservative forces. Again, ignore the proof for the potential energies, and then don't worry about the relationship between force and potential energy. So kind of with the energy stuff, very similar to how we approached it for exam 2. Kind of all of it is fair game. 11 was our translational or linear momentum. The momentum review video is going to combine both types of momentum together. It'll just be conservation of momentum as a whole. So understand the relationship between momentum and impulse. Again, impulse itself not explicitly mentioned, but it is related to force, so you probably see it in conceptual. Be able to do conservation of momentum in both 1 and 2 dimensions. We have talked about 2 types of collisions, elastic and inelastic. So probably would like to review those. In particular, we've looked at the perfectly inelastic collision where the objects stick together, and the elastic collision where they don't. So we'll, understanding when to use each one and what it represents. We didn't talk about reference frames, so we're going to skip that. We talked about explosions, but not very interesting questions you can do for that, so we're going to ignore it. And then for rocket propulsion, we didn't really cover that because it involved a little more calculus than we were ready for at the time. So you'll probably just see it again in 130. So chapter 12. So this is the chapter that we began kind of refreshing everything, but now we were looking at objects that rotated. So, oops, I forgot to move this. Static equilibrium shouldn't be here. Slap that over in the ignore portion. So for chapter 12, study rotational energy. So this was for, typically we were seeing it with rolling. We saw this on exam 3. Yeah, exam 3. So that probably means you might not see it explicitly again. Torque and rotational dynamics, so how torque causes an object to rotate. So that's calculating a net torque, going through and using rotational kinematics to solve for some stuff. There is some request for a torque video, so probably goal is to make a torque video as well that will combine the rotational dynamics in it. Because static equilibrium is a subject we're going to ignore, don't study it. Ignore it. Pretend it doesn't exist. I know a couple people wanted to cover this type of topic. Not important for this exam, so I'm not going to cover it again. Angular momentum. Again, this is going to be put into the momentum video, but understand it's got a bunch of equations. We'll look at combining the 2 types of momentum, angular and translational, together. We then skip a bunch of chapters to 15. Just focus on simple harmonic motion for a spring. Pendulum, you guys, again, it can be in the conceptual. As of right this second, I have not written the exam, but I'm leaning towards the fact that pendulum's probably not going to be on the exam at all. But I wanted to put it here just to make sure I gave myself the chance where if I had a good pendulum question, I can put it. So with simple harmonic motion, we talked about it. At this point, without going further into the material, am not certain there's anything more interesting I can test you on that I haven't already, so probably not going to show up in problem solving. I know forces and energy are in there, but we can do more interesting questions with forces and energy with non-simple harmonic motion. And still we can ignore the vertical oscillations. Chapter 16, if it's on there, it's going to be conceptual. That's it. Kind of the same thing as exam 3. I would understand charge interactions in Coulomb's law. Again, this was on exam 3. Same with, so I'll just go to 23, right? The electric field for a point charge. I already tested you guys on it. Not really much more interesting stuff we can do with that. I can give you a more complicated shape that doesn't have as nice of symmetry, but then I have to grade it, and I'm gonna be honest, I don't want to. So that might tell you how that's gonna end up on the exam, yes or no. Again, if there's anything related to electric field lines, kind of similar to the first question on exam 3, It's going to be stuck in conceptual. All right, so chapter 27. So this point onward was not on exam 3. However, if you again go back and look at what you are supposed to learn in this class, none of this is exactly related to what you are supposed to learn in this class. So, what you should take away from these next couple of, it's not explicitly listed on here, but it's probably just going to be in the conceptual portion of the exam. That's just going to be the way it is because I need to, we need to focus on forces, energy, momentum, and motion. Yes, there is motion in here, but it is not technically mechanics, it's electrodynamics. So with that, I don't know why. I meant to move this conductivity and resistivity. Slap that over there. You're not going to be using it to calculate anything. So understand what current is, so it's charges per time, and Ohm's law. You should know the difference between conventional and electron current. Chapter 28, know what Kirchhoff's laws are. Know how to calculate the equivalent resistance for resistors in series and parallel, but you can completely ignore resistor circuits. There is no problem-solving question involving resistor circuits, which means I am not going to be making a video about that because I don't think it's going to be, and by I don't, I mean I know this is not going to be a problem-solving question on this exam. So that means you're going to be able to ignore that question for summer 19 on the exam for studying because it's not going to be relevant. We ended up spending about 2 weeks on it for that version of the class because they were interested in it. We spent 2 days on it. I don't feel comfortable with how much we've skipped putting it on the exam. So no resistor circuits. The last thing we talked about was chapter 38, the quantization of energy of an atom, in particular the electrons only having specific energy values. And we talked about Bohr's hydrogen atom, which had, depending on where the electron was, we could calculate the energy as well as the radius. Again, if this is on here, it will be in the conceptual portion of the exam. You're turning in the homework on Monday for this chapter, and you might have, by the time the solution goes out, which ideally will be on time, right, you'll have about 24 hours to look at the solution. That's not enough time to make a problem, for me to feel comfortable testing you problem solving wise for it. So if it's on the exam, it will be in conceptual. All right, so that's going to wrap it up. This is all the stuff we've covered. This is a really brief overview of what to study and not study. Again, I'm going to be putting out videos relating to some of the questions you guys have asked about associated with the top secret quiz. So as of right this second, the 5 videos I will be making are going to be based on kinematics, forces, energy, primarily with friction. We're going to look at momentum with both angular and linear, and rotation. So it looks like there's going to be 5 videos. That is not the order I'm going to be making them. That's the order we covered them in. But those are what I'm planning as of right this second for making videos on. Again, this is based off of what you guys want. We'll also be trying to make some other kind of like review topic, like not like a full packet for each thing, but kind of like, hey, like here's some key aspects to combine all this together. So review material will be going up kind of throughout the week. I'm still finalizing grades for exam 3, so ebbs and flows in what I am working on. All right, so again, if you have questions about the final, please let me know.